Yeah, folks, we are live now. So, hello everyone. I hope you all are doing well and enjoying your festival as well. Like, as you all know, Holi is coming on. So, I did like to welcome you all in the amazing workshop of Web3 Init Hack. And Web3 Init is a month-long hackathon with backed of amazing swags, networking opportunities, prizes, and many more and unforgettable experience as well. So, one more surprise for you all folks, like we will be giving away GitHub goodies. So, do check out our Twitter for that and participate in that as well. And so, let's start now. So, today we have Ganesh with us. He is working as a technical lead at DevWorld, and today he will guide us on NFT architecture and dynamic NFT, and will be available to answer any type of question that you have. And Ganesh, would you like to introduce yourself?
Yeah. Hi, good evening. So I am Ganesh. I have been working in this blockchain space for 4 years now. Earlier, I used to do freelancing in this domain. Like I have built many applications in Web3 for clients, and then started DApp World around March 2021. Basically, it was a DApp marketplace then, but we pivoted to upskilling platform in December, I guess. Now we are focusing on upskilling people in blockchain. So that was all about me.
Yeah, awesome. Then we can start with the presentation and other things.
Yeah. So I will quickly share my screen. Okay. Is my screen visible?
Yeah, your screen is visible.
Yeah. Okay. So let's start. Actually, I'm facing some electricity issues in my area. So there is some darkness here. Okay. So let's get started. We will discuss the NFT architecture and what are dynamic NFTs in today's session. So NFTs has been really hot topics these days, right? The non-fungible token ones. And now that NFTs are like introduced way before, it's time to switch to dynamic NFTs, because dynamic NFTs has much more potential than the static NFTs one. So today we will see what are dynamic NFTs and how to build. Basically, we are not going to code anything, but in some part we will be discussing some technical terms as well. So if you are developer or non-developer, you can comfortably listen to this. So these are the topics that we are going to discuss today. The first part will be blockchain and smart contracts. What gives the NFT powers, what is the engine that powers the NFT, then the basics of fungible and non-fungible tokens, what's the difference between fungible and non-fungible tokens, then we will discuss the architecture. This architecture will be mostly based on the EVM kind of blockchains. So that's it. And then we will start discussing the dynamic NFTs, how we can switch from the static NFTs towards dynamic NFTs, what are they, and where they can be used, their technical challenges and future potential, etc. And then we will see technical challenges and use cases and future potential of dynamic NFTs. Okay, so let's start with the first part, the basics, blockchain and smart contracts. So the blockchain, as the name suggests, is a chain of blocks which is joined together with hash, right? So blocks are nothing but the database which contains the transactions and which are joined with chains. And these chains are hashes. So I will discuss this in detail in later parts. So the main pillars of the blockchain technology are decentralization, immutability, and consensus algorithm. So let's talk about decentralization first. So currently the architecture for any application is like this. there are users, multiple users, which are using any applications or mobile applications, web applications, etc., which is governed by the central authority, which has a complete control over the users database or users personal details, etc., etc. So the current system is totally centralized. You can think it as a boss who gives orders to its employees. And the decentralized systems is different. Like the it's a set of nodes that work together, that no one has a complete authority on what to do, and what to make changes, or what to add in the database. So let me give you a quickly example. You can see the fiat currencies. If we take an example of rupees, the fiat currencies, which is backed by RBI. RBI has a total control over the fiat currencies, right? Like the demonetization, it's not in our hands that whatever the RBI decides, we have to just follow it blindly. So, and but the Bitcoin, at the other hand, is different. It's actually governed by the set of people, and Bitcoin has no any central authority. So if that's the case, then who is going to check out or look after who is paying whom, or keep the transaction records, and keep look after frauds. So it's easy for looking after frauds in the fiat case, because RBI handles all the transactions. RBI looks after who is paying who has the balance and all that stuff. RBI is the only central authority here. But in the case of Bitcoin, it actually is governed by the consensus mechanism. So the next slide is about consensus mechanism. So basically, when you transfer Bitcoin from one address to other address, the consensus mechanism will actually govern that you are not making any fraud, that you have actually that balance in your wallet, right? And then the next proceedings, like whether this transaction is valid, legit, or it's just a fraud. So there are different types of consensus mechanisms, like proof of work, proof of stake, proof of authority, etc. So proof of work is being used in the Bitcoin, and currently Ethereum of work to proof of stake. uh, each individual consensus mechanism has its own pros and cons. We are not going to discuss them in detail. We can do it in later different sessions. So users need to understand that in case of central authority, the authority manages or looks after all the stuff that's going over in the uh, transactions. But in the case of blockchain, it's the consensus mechanism which governs whatever is happening on that blockchain. Then the next one is immutable chain. Like in case of central authority, if the central authority has all the kind of power, that it can alter any databases, and no one can actually see what the central authority has done. But in case of blockchain, as I already told you, it's a chain of blocks that is actually joined together, linked together with the hashes. So hash is just a random number which is generated by giving some input. It's something related to the cryptography. We will see what is cryptography in the next slides. So you just think of this as you are giving some A input to the cryptographic function, and it's giving you some Z output. If you change the A, then Z will also change. And if you again give the same input, it will generate the same output. It's like one-to-one function. So the first block, it contains all the transaction data. It has some hash A, which is then linked with the next block adjacent to it, and then the previous block's hash plus this block's data. These are complete. These are joined together and generated. This generates the hash B. Then this process continues, like this previous block's hash is then added with this block's data, and like that. Now suppose anyone comes here in this block, and changes some data in this block data. Now the hash C will change, right? Because the block data, the input is changed, that's why the hash C will change. So hash C changed, that means this hash D will also change, because hash D is generated with the help of giving two inputs, the previous block's hash plus this block data. So likewise, hash D will change, hash E will change, and all the hashes will be changed. And it's very easy to look which block is actually altered or affected. That's why we call it as immutable. We cannot change the data once it's added, right? Then the next thing is wallet and keys. So basically, in Web 2 applications, uh, the Web 2 applications keep the track of users, like who users data or users activities on the application, with authentication systems. Like you can use Google, Facebook, GitHub authentication systems, etc. And that will be your unique account on that particular application, which which actually checks whatever changes or whatever activities you are doing with it. But in case of Web3, they are the wallets. So wallet is nothing but something that stores your private key and public key. The private key is basically, you can consider it as your bank password, bank account's password, which you should never share to anybody. And the public key is like the account number, which you can share. So every user uses his private key to sign the transactions and then send it to the blockchain. So this was all about the wallets. Then the cryptography, as I discussed earlier, that the cryptographic hash function is one-way function. Suppose you are passing hello world as an input to the cryptographic function, will generate some fixed string according to the cryptographic functions. There are many like SHA-256, KCAT-256, etc. It's very it's very hard to check or guess what was the input from the output. If suppose if someone has a hash, then it's very hard to guess what was its input from the hash. But from the input, it's very easy to convert into the hash. Okay, so this was some basics. Now let's check what is the transaction life cycle here. Suppose one user on the Bitcoin network is sending some Bitcoins to other user. So what is the actually life cycle to it? Suppose the Bob sends some Bitcoin, then the transaction is actually created, then it's broadcasted to the network, and then the transaction is verified and added to the blockchain. And this is where the consensus mechanisms comes into picture. The consensus mechanism, the nodes which we call as miners or validators, based on which blockchain they are using, they are responsible for validating your transaction, that your transaction is authentic and you are not making any frauds. So once they approve, validate it, then the transaction is complete and the coins are transferred to the other user. But in case of the centralized system, it's the centralized authority which looks after this process. Okay, so this was all about the transferring some data. It was all related to just transactions and all that stuff. Like you can just send some virtual currency from one user to another user on over the blockchain, and it was all the case until the Ethereum came into picture. The Ethereum blockchain actually introduced something called as smart contracts. Now, what are smart contracts? Smart contracts are just like the code which we write in any languages like C, JavaScript, and all that stuff. But this code is actually stored on the blockchain itself, and it executes as per the rules written in the codes. And the smart contracts actually contains all the benefits that the blockchain contains, like its decentralization, immutability, and transparency. So whatever happens in the smart contract, sorry, on the blockchain, it's all transparent. So suppose there is some dApp. Let's take an example of Uniswap. Uniswap is a decentralized exchange where you can exchange two tokens with each other. like some two tokens, suppose let's say polygons, matic and ethereum, you are exchanging them. So you can completely trust that you will get the exact amount of matics, equivalent amount of matics for whatever ethereums you are wishing to exchange, because the smart contract is written like such that, and it's completely transparent. You can completely go and check their codes, and you can see their previous transactions done on the smart contract. All the stuffs is transparent and visible, but that does not mean that you can actually see which user has made transaction. All that data is actually hashed in the is present on the blockchain in the hashed form, like this one. So you cannot guess uh, which user is this from just the public key and transaction IDs. So with the help of the smart contracts, now the applications which were normally in the production, they actually the applications which are using the smart contracts, because the smart contracts native functionality, the decentralization, the applications built on top of smart contracts are called as decentralized applications, or in short form we can call it as dapps. Okay. So this is one example of smart contract which actually stores one integer on the blockchain and then reads it back. So this smart contract over here is written in the Solidity programming language. Solidity is just like JavaScript. It's not that much of hard, but you need to understand the EVM architecture, like the gas, the public-private keys, then some of the terms like compiling, deploying, all that stuff. We will discuss in upcoming thing. Okay, so this is interesting. The current application stack looks like this. This is the end user which interacts with the front end. So whatever you see on your mobile phone devices or the browsers, web browsers, so you interact directly with this, like buttons, images, inputs, media files, etc., etc. So after interaction, this front end interacts with the back end, and at the back end there are two things: the server and the database. The server is you can see the server as the which serves the request. So suppose if you click on the if you click on the button over here, then its request will be sent on the server, and the logic which is written at the backend will be executed. Now if you want to update any databases which is stored, then you can directly do it from the server. You can directly update your databases. So this part is completely under the control of central authority of that particular application. For example, let's say YouTube or Facebook, you cannot see with what kind of data they are actually saving, or what kind of request, what's the logic, what is happening here. You just know their front end. In case of decentralized application, you can see the stack is like this. This is the blockchain here. We save the Solidity smart contract on the blockchain, and this data can be actually accessed by from the servers as well, from the front ends as well, and directly by the users as well. So this is actually the stack. So as the blockchain is transparent, anyone can see what's happening here. Like I mentioned the example of Uniswap, like you can actually see who is making transactions, how many tokens are there, etc., etc. Now the next thing is, what's the development path? First, you should have a Solidity smart contract with you. You need to compile it. You once you need to compile it, look for the syntax error and compilation errors. We can do this using Remix ID. Remix ID is basically online integrated environment where we can directly develop the smart contracts, test it, and interact with it also. It provides some test environment also. So once you compile, and you are comfortable, then you can deploy it on blockchain networks. So here, actually, blockchain networks, there are two, three kinds which I would like to add. The main network, which is actually the main, means real, which is, uh, you can say, the transactions that are happening on the main network or the assets on the main network are like a real kind. And the next one is private networks and test networks. Once you build your smart contracts, you need to test it actually before deploying it to the main network. So for that purpose, there are many test networks. To talk about Ethereum, there are Gorley. Earlier, it was Ropsten and many more there. In case of Matic, it's Matic Mumbai. So you can test on the public test network. Public test network is just like the private network, but all the things on that public test networks will be the fake one, the tokens, the transactions, all that stuff. The working will be the same, it will be public. If you are testing on the public test network, that means whatever you are testing on that network is visible to everyone. The next thing is private networks. Private network is, like the name suggests, you have to actually set up on your local machine. uh, in case of Ethereum, it's Ganesh or hard hat, which actually provides you the setup for testing on private network. The main advantage of testing on the private network is like it's very fast because only your transactions are processing here. But in case of public, whoever is actually testing on the public test network, all that transactions are going to be processed. And once you deploy the smart contract on the blockchain, then the thing remains is you need to connect and interact with it. Now, as I said, the smart contract, you can interact with it from the servers, from the front ends directly, and from the users as well. So in case of front end, you can use the wallets, right? Like MetaMask or Trust Wallet and all that stuff. But the wallets currently, as of talking about the current architecture, the wallets are present as an extensions for many blockchains, may it be Solana or Ethereum or any other. The wallets are present in the form of extensions in the browser, and they are not actually accessible in the server side. The browser extensions are not, so you will have to provide the raw your private key and all that stuff if you want to interact the blockchain from smart contract from the server side, right? So this was all about the development part. Now, now what happened is, uh, the Ethereum community saw that there are some kind of smart contracts which working functionalities look a lot like similar. So they introduced something called as ERC standards. Now, what is ERC standards? ERC standards is Ethereum request for comments. They're basically the technical guidelines. So instead of developing independently smart contracts which function a lot like, they introduced some technical guidelines that if developer develops some smart contract which are which resembles according to our technical guidelines, like if they declare such function name like such data, then we can recognize it as some of the ERC standards. So there are many ERC 20, ERC 721, and ERC 1155 are the most popular one. The ERC 20 is like developing your own token on blockchain. The NFT ERC 721 and 1155 actually they extended from just deploying the token to the non-fungible token. So I guess these basics are okay, and all of your basic understandings are now clear. Now let's go for fungible and non-fungible tokens. So before that, let me discuss with the native tokens and the custom tokens. So For any blockchain, you can actually build your own token on top of blockchain. So if we talk about particularly Ethereum, the Ethereum's native token is Ether. The native token is used to actually, spend as a gas fees, or uh, you know, the miners will be mining it, all that stuff. So that's the native token, which is built on top of blockchain. What is custom token then? The custom token is developed using one of these ERC standards. Like I mentioned, that if you follow some certain technical guidelines, that if you build such kind of functions in your smart contracts, then we will recognize your smart contracts as one of the tokens. So it's really easy to build your own token, like it's just on one button. So that was the difference between native tokens and, yeah, custom tokens. So let's talk about their properties now, the fungible ones and the non-fungible ones. So fungible tokens are basically interchangeable. You can consider the fungible tokens as fiat currencies. If I change 1 rupee coin with 1 rupee coin, nothing is affected, right? The value is not actually transferred between the parties. It's just replacing the coins. But it's not the same case in case of non-fungible tokens. Like if I want to change my Audi with your Tata, it's not feasible, right? The value is actually different. So fungible and non-fungible, basically fungible changeable, but non-fungible are not. Then indivisible. Now suppose if I give you 5 rupees and you are giving me 5 coins of rupees 1 month, then it's okay, right? The value remains the same. So it's divisible. Like 20 rupees note can be equivalent to two 10 rupees note. But that's not the case in case of non-fungible token. Non-fungible tokens are, not divisible. Like if I give you some of my necklace or all the any other valuable thing, it's not divisible. Like you cannot give me some two different things instead of that one thing. Then the third property is identical. So the tokens are identical with each other. Like if we see the rupees is equal to the rupees, right? But non fungible tokens are not identical. You cannot compare them. Then next one is unique identifying features. Like fungible tokens cannot be identified, right? If I give you some 5 to 10 notes of 10 rupees, they look like the same. They are not unique, right? But non fungible tokens are unique. If we talk about some examples, Ethereum, Bitcoins, or even fiat currencies, you can say, are the fungible ones. And Bored Ape collection and all that stuff, which is unique and cannot be, copied, they are called as non fungible tokens. So often, very people who are contacted me, who are in contact with me, they ask one question like, if the Ethereum is non-fungible token, then why its value keeps changing over a period of time? Like when the 10 years before, 5 years before, 2 months before, the value was different and currently the value is different. So in this case, basically we are comparing two different fungible tokens. Like it's like comparing the rupees with dollar, right? The value may keeps changing, but the 1 rupee will be always equal to the 1 rupee. So that's the case. So that was all about fungible and non-fungible. Now talking about the ERC standards, you can develop your fungible tokens using ERC20 smart contracts. You can develop non-fungible tokens with ERC 721 standard. And if you want to implement them both in one single smart contract, then you can go for ERC 1155. Okay. So let's talk about some of the features of non-fungible tokens. The main thing is it provides true value to the digital asset. Suppose you have one digital art there on cloud, you have stored it on cloud or uploaded it somewhere. how will you actually value it, right? So if you store that same art on the blockchain, now it will get some value attached to it. The next thing is its ownership. You can easily verify who is the owner of the digital assets on the blockchain, because the blockchain's core functionalities like decentralization, transparency, all that stuff, which we already have discussed. Then the uniqueness, like that kind of token will be unique in its own. It's transparent, like I have already discussed that if you transfer your art from one user to other user, everybody knows it, like you are changing your ownership and you have done a transaction there. And the main thing is it's stored on blockchain. Okay, so that was all about the fungibility and non-fungibility. Now let's talk about the NFT architecture. What's actually the architecture? And now from here onwards, the developers, the developing part will be discussed. We will discuss the developing part, like from the developers' point of view. So the ERC 721, as I already discussed, like it's a standard which ensures that the tokens are compatible with wide range of applications, because they are uh, developed using some certain technical guidelines. And it also offers the platforms and makes them more accessible to the users as well. Then the smart contracts, like this ERC 721 is basically limited to the EVM based blockchain. Whatever the blockchain which supports the EVM architecture, they will have access to this ERC 721, and you can deploy them on that particular blockchain. And this standard was first actually proposed by Data Shelley in September 2017. So now the thing comes here, like if there is one NFT which is residing on blockchain, then how can I identify that NFT, right? How can I know that it's unique? So to identify any NFT on the blockchain, you need to have two parameters with you. The first one is the smart contract address. Like many users can actually deploy ERC 721 smart contract, right? They can deploy their own collection, they can deploy their NFTs. And one more thing I forgot to mention is that the single smart contract can hold multiple multiple NFT tokens. Like if I deploy one ERC 721 smart contract, then that does not mean that the ERC 721 smart contract is the NFT, single NFT. And then again, if I want to mint a new NFT, I need to again deploy the ERC 721 smart contract. It's not the case. Once you deploy the ERC 721 smart contract, it can hold multiple NFTs in it. So to identify the NFT on blockchain, first we need contract address of that ERC 721 smart contract, and the next parameter is token ID, because that smart contract address may contain different multiple NFTs. So you need to have one more additional parameter here, and that is the token ID itself. Okay, so what's the workflow here? The catch is, whatever digital asset you have with you, that digital assets cannot be stored directly on the blockchain. You cannot store the file or image or audio or video on the blockchain itself, because it will cost a lot of gas, because that data is too much. And currently the Ethereum or Polygon or the blockchain doesn't support for storing large chunk of files. So what do we do here then? So basically what do? We upload this digital asset on some storage which is decentralized by nature. It's not mandatory to use decentralized storage. You can use centralized storage like AWS, S3 buckets, or Google Cloud Storage, or even the Drive also. But then it again, the centralization part comes in here. So it's good to store your digital assets on the decentralized storage. So IPFS is one of the best examples where you can upload your digital storage. Once you upload your digital file on the decentralized storage called IPFS, then you have its link, like where you can access that digital asset. You have its link. it will be like in the form of https/ipfs.io slash something and then some hash. Then once you have its link, you will have to prepare something called as metadata file. Now, what is this metadata file? Basically, it's a file which contains some additional information about your NFT, like the path where the NFT is stored, the name of that token, the description of that token, like uh, if you want, if you can give it whatever you want to, and the additional attributes like if you want to add its traits, like if it's wearing color, shirt color, its brand color, shirts brand, etc., etc. So the attributes, in case of some gaming examples, its stamina, its power, its energy, and whatever it is. So you can customize it according to your use case. And once you have developed the metadata file, then this metadata file you have to again upload it on the storage, like the digital asset. This metadata file also goes to the storage, and this link then you save on the smart contract. So I hope you are following this workflow. The digital asset is not going to stored on the blockchain directly. You have some function here in the smart contract. We will discuss which function is this, that accepts the URL which points towards the metadata file. This URL doesn't point directly to the digital assets. It points towards the metadata file, and then this metadata file has some attributes like the storage link, the title, and all that stuff, which actually contains where the digital assets is stored. So this is the complete workflow. The functions, right? As I mentioned, in the ERC 721 smart contract, you have to follow some certain kind of guidelines there. You have to create such kind of events, such kind of functions. The name should be like this, the working process should be like this. You can definitely customize it according to your needs. So the functions that are actually recommended to build ERC 721 smart contract in order to recognize it as an NFT smart contract by other peoples. The first is name, so whatever the name. So for DApp World, we have already one collection which has some SBTs. SBTs soulbound token. That's another part. So it look like this, the name on OpenSea, or if you go to the Explorer, it's here. Then the symbol is just an abbreviated form of the name. You can, like, it's if it's DApp World, then you can use it DW, etc., etc. Then we will see the complete procedure of how this ERC 721 smart contract works. So there are some storage variables that are declared in that smart contract, and the functions. So we will discuss this. We will take the help from Open Zeppelin's already developed smart contracts. But the owners here, the mapping is like table which maps from element, left element to right element, left element to right element. That you can consider it as a table. So this owner storage actually stores the token ID to address, right? Which NFT token ID is assigned to which address. So for this token, this is the owner. For this token, this is the owner. So in the mapping, the next one is balances. Balances means particular user owns how many NFT tokens. Then the token approvals. Token approvals and operator approvals are actually interesting things. Like approvals means you can actually give any third party user uh, privilege to use your NFTs on behalf of you, right? Like if you have some NFTs in your account, then the third party user can actually interact with your NFTs. They can sell, they can buy, and all that stuff. So operator approvals actually gives complete control over the your complete control over your NFTs. The token approvals gives some tokens, not the complete tokens, uh, approvals for third party. Then the next functions, the balance of this function actually gives how many tokens a particular user have. The owner of function will return who is the owner of that particular token. The token URI function actually returns the metadata URL, which is stored for that particular token in the smart contract. The base URI is actually interesting here. The token URI and base URI. We will see these two things in the next slide. Then gate approved and all that stuff, operator approved, all functions we are not going to discuss. Then the internal functions are there, like the transfer. If you want to transfer one token from another token, you just have to change the uh, data stored in the owners. You just have to alter the address here. So the transfer. The mint one is mint and burn is they are the opposite things. Mint will create a new token, burn will destroy the already created token. So these were the functions. Now let's see the smart contract itself. We'll change the tab. Let's go to the Open Zeppelin smart contract. Okay, so this is the Open Zeppelin's wizard, where you can directly tell Open Zeppelin what kind of features you want, what kind of what is your name of the, what is symbol, what is base URI, and all that stuff, and it will generate the smart contract for you directly. So I think this is it. Let's discuss the features first. So if you add the mintable function here, it will add the safe mint function, which actually uses the safe mint function which is defined in the ERC-721 Sol. We will discuss that one also, that too also. Then you can customize here my token and all that stuff, and it will accordingly customize it. Okay. So the next thing is, you can see that here the safe mint function is accepting two parameters, to whom you are actually minting the token and what is the token ID. So if you are willing to create a new token, then who will be the owner of that token, and what will be the ID of that token. So if you don't want this, because sometimes you have to keep a track of IDs, like uh, you can generate this ID randomly using Chainlink and all that stuff also. But sometimes what happens is you don't want really to keep a track of this token ID. So in this particular case, we can use the auto increment IDs. Now, what happens if you use auto increment IDs is the default ID will be 0, and whenever you mint a new token, the counter will increment the ID and directly add this in the safe mint function. So the counter, you don't need to get this smart contract from here. You can implement it or store it in it here itself. But as it is provided, as the Open Zeppelin has provided, they have used here. So the current token ID is stored in the local variable, then it's incremented, and then it's passed in the safe mint function. Next thing, if you want to implement the burnable function, burnable, as I said, the burn function will actually destroy the minted token, and you can follow other things as well from here. Now the URI storage, uh, the URI storage is basically interesting. Actually, what I was going to discuss is the difference between the base URI and the URI storage, right? So for that, actually, I need to go to the contract itself. So just a second. Yeah. So this is the smart contract from the GitHub, yeah, Open Zeppelin's GitHub library, where you can find all the implemented functions and all the storage that we have discussed. And from here, you can see we have one function, token URI, which actually returns the token URI where is that metadata file is stored by accepting one parameter token ID. Just you just have to pass the token ID and it will return the token URI. Now the thing is, if you uh, if you are saving all of your NFTs metadata file on similar platform like IPFS, if we say, then you don't need to add the token URI always there, right? Because the domain, the string in that domain is same. Like suppose if we look at this URL here, for all the things that are stored on the IPFS, this part will remain constant, and this part we don't need to add recurringly here while minting new tokens, because you are reducing the length of string that is stored on the blockchain. You can actually save some gas tokens here. So for that purpose, we have base URI here. Once you define what is your base URI, like this is my base URI, like on this domain, my all NFTs will be stored. You just have to define the base URI, and it will directly add the token ID in front of it. So suppose if your NFT has a token ID of 5, then what will be your metadata URL? Like it will be like https/ipfs/ something, which is complete base URI slash the token ID, which is 5, right? So it will be encode pack. Here the condition is checked if the base URI is declared or not. Dot length means it's declared, and if it's greater than 0, then it will concat. Concat means joining the two things. Which two things? The base URI, the the base URI, and the newly minted token ID. So /5/6, whatever it is. And if the base URI is not declared, then nothing. So for if you are not saving your tokens in a particular or common storage platform. Suppose if you are storing your half of the tokens on IPFS and remaining half on some other platform, then you will have to use the URI storage, right? So I guess this was all about the architecture of the current NFT, the static NFT, static one. So whatever the digital assets you have stored here, these digital assets, you cannot change it, right? Once this is stored, you get the link, you prepare the metadata. This is once it's gone in the smart contract, it's there. If you want to update the smart contracts, if you want to change anything, then you either can define your own customized function in the smart contract which changes the token URI of that particular NFT, or there is one more thing, like for if we are following this path, then you have to actually spend gas fees all the times when you are changing the URLs. So let's check what are dynamic URLs now. Now whatever the digital assets is there, for example, suppose there is one game, right? And in that game the user level keeps incrementing, and as the user levels keep incrementing, the avatar of that user keeps has some more accessible elements. For example, when the user joins the game, the base NFT is like this, the solo user's avatar, right? Now, if the level is upgraded, then we can actually give him some bow and arrow or some other stuffs or some hidden traits unlocked. We can add all that kind of stuff to his avatar. Now, for the current architecture, which is based on the static NFTs, once you have uploaded this base avatar, which is literally a JPG or PNG, it cannot be changed or updated. Now, if you want to update this, then you have to create a new JPG, upload it, and then change the token URL. So, so the dynamic NFTs and the static NFTs has basic differentiality is this: the static NFT keeps as the static NFT won't change depending on any particular situation or time, but the dynamic NFTs keeps changing according to some certain trigger or time. So what are the possible ways to implement this dynamic NFTs in our application? We can actually work on this part, right? So the digital assets which is stored here, and we have got the link and the metadata. So if we have some architecture, or you can say some algorithm or code developed which actually controls the metadata, we can change the metadata file, right, without spending any gas fees or anything. So suppose if I change the attribute here, the NFT's attribute will be automatically updated here. We are not dealing with smart contract at all. So if I change the storage location of this NFT, then this NFT will be changed, right? So the earlier NFT will won't be there, the new NFT will be there. And that too, we are just using the metadata file, we are just updating the metadata file, right? So this is the one case. And the next case, as I told earlier, that you have to completely change up to the smart contract point. So there are some things that we need to consider, like using the centralized storage or the decentralized storage, because if this can be done, then what's the point in it, right? So suppose if I have you know a portrait of Mona Lisa, suppose, and I have minted its NFT, and I know that it's unique, and the ownership and all that stuff can be actually verified on the blockchain and blah blah blah. Now, suppose someone comes and changes the metadata file, and it actually changes the Mona Lisa portrait to some else, suppose the Da Vinci portrait. Now, the same NFT, which was earlier showing the digital assets linked to the Mona Lisa, is now showing that it was not the Mona Lisa, it's the Da Vinci's portrait, Leonardo da Vinci's. So for this stuff, actually, we have to use decentralized storage systems like IPFS. So what IPFS does is IPFS is uses kind of cryptographic hash. So if you change the file, its URL will also change. Now, if we update the metadata here, then the whole link for this metadata file will also change. So suppose if you have written A, B, C, D in this metadata file and uploaded to the IPFS, and you have got the link like IPFS slash ABCD. Now, if you change here, instead of ABCD, if you write XYZ, then the link will also change. It will also be the slash XYZ. Then whatever whichever link is stored here, it will show that metadata file only, not the updated one. So for that stuff, we have to actually build some decentralized mechanism which actually keeps track of this changes, and that's where the revise SDK actually comes into picture. We have a complete course on how to build these dynamic NFTs using this revise SDK. So you can directly go to the DApp world and then courses and find the dynamic NFT introduction and take the course. So the interesting part is we can actually extend this functionality as well. Like suppose your NFT, which is the base NFT, is actually dependent on the weather. Like if there is a cloudy weather, he wears a hat. If there is a rainy weather, he has an umbrella, or etc etc. Then how you can implement it? So here we can actually use the oracle system. So oracles are nothing but the bridge between the real world data and the smart contracts. Like the traditional thing, like we can directly integrate any third party API into any SDK. We cannot integrate the third party API directly into the smart contract. So this is where the oracles come to the picture. One of the example of the oracle is Chainlink. So you can directly read the real world data. So suppose there is a provider which provides the current weather situation based on the location. You can actually read the weather situation in this smart contract and then update it accordingly. So we can see that this is the interesting extended functionality. So that was all about the technical part of building dynamic NFTs, how we can migrate from the static NFTs to the dynamic NFTs. And let's see what are the technical challenges for building such kind of things. Now, to build such kind of thing, even for the static ones, there are these issues, or you can say challenges. And the dynamic NFT actually adds even more things or stuffs in that. So the first thing is scalability. Uh, this is the headache for all the blockchains, like how you will scale. So Ethereum says we have layer 2 solutions, and we are sharding, we will be having 64 shards. You can use roll ups and all that stuff, side chains, but still scalability is a headache. So how you are going to scale this stuff? The only thing uh, that was updating until now in the static ones is this, the smart contract, and now you are saying that you have to update this part also, and that too in a decentralized way. So the scalability thing is definitely one point. Then the storage and bandwidth. Now for the dynamic things, there will be multiple versions of the digital assets, right? And the multiple versions that are based on different situation and external triggers, you have to send it to the user. So suppose you are using any game and certainly there is one trigger, your digital assets will also keep also update. It won't be the same anymore. So how are you going to manage the storage and bandwidth? That is also one uh, problem. Then interoperability, this is the main headache. How are you going to sync all of your things across devices, across blockchains? So across devices can be managed, it's not that much of hard. Like if you are playing in Windows, then switch over to the Linux or Mac, or on the browser from Android to iOS, that can be managed. It's not that much of hard part. But how are you going to manage the interoperability across the blockchain? Now if I have something which I own on Ethereum, and now suddenly if I switch to Solana, suppose the other application uses Solana, so how I am going to use that uh, the value which I have created on the Ethereum ecosystem in the Solana ecosystem? So interoperability is also one of the thing. And then the security is like a constant to anything. Like if you build on web 2, build on web 3, security always comes here. So what are the use cases then? Like obvious use cases, gaming, right? Because in the gaming, as I said, your character keeps up leveling up, your character gains some accessibility, and keeps on improving. It's a dynamic thing, so gaming is the obvious one. Then collectibles and arts is another thing, and the real estate and the DeFi. Like real estate, suppose there are fractional NFTs, like for single apartment, you are going to rent two bedrooms or kitchen and all that stuff, different to different parties. Then how are you going to manage that? Or if you have a plot of say 100 by 100 and you are wishing to sell it 25 by 25, 25 by 25, then the whole 100 by 100 will be your one NFT, and now you are wishing to sell some part of that NFT. So this is where the dynamic NFT can come into picture. Then the DeFi, obviously, borrowing and lending, all that stuff. So that was all. Now I'm open for any questions. If uh, hello.
Hello, folks. Hope you enjoyed the session. And now, thanks, Ganesh, for this amazing session. And before we close, do you guys have any question? and I'm unable to see any question. Like if you have any question, you can directly contact Ganesh on his Twitter handle. I think he is most active there because all the web developers will be going to be active on Twitter. And apart from that, I'd just like to remind you all, like our hackathon registration is going on, and if you are willing to participate in hackathon, build some awesome project, and learn more about Web3 space and build some awesome projects in the span of one month. So go ahead, build a project in this particular hackathon. And let me just show all this detail in the chat itself. And I would just say thanks for joining, and we will be back tomorrow with another great session. And thanks for joining as well. So for applying, you can directly go through this particular link.